We've discussed some concepts in the calculus course which are related to circuits course. Next, we will introduce some concepts in the linear algebra course which are related to circuits course. Firstly, let's discuss the linear property. Suppose y is a function of x. The term homogeneity means if x changes to ax, in which a is a constant, then y changes to ay. The term additivity means if x is the sum of x1 and x2, and the corresponding function's value are y1 and y2 respectively, then the result is y equals y1 plus y2. If one function satisfies the homogeneity and the additivity, it is a linear function. Now let's verify some common functions to see whether they are linear ones. For example, y equals x. Firstly, when x changes to ax, y equals ax equals ay, which satisfies the homogeneity. Secondly, if y1 corresponds to x1 and y2 corresponds to y2, then y1 plus y2 corresponds to x1 plus x2, which satisfies the additivity. So y equals I is a linear function. Next, let's see whether y equals x plus 1 is a linear function. When x changes to ax, y equals ax plus 1, but not equals ay, also not equals a times x plus 1. So y equals a times x plus 1 is not a linear function. Next, is y equals x squared a linear function? We verify the additivity firstly. Suppose y1 corresponds to x1 and equals x1 squared, and y2 corresponds to x2 and equals x2 squared. Then y equals x1 plus x2 squared equals x1 squared plus x2 squared plus 2 times x1 times x2. It equals y1 plus y2 plus 2 times x1 times x2. Generally speaking, it doesn't equal y1 plus y2, so it doesn't satisfy the additivity, and y equals x squared is not a linear function too. Next, let's discuss a function you may not be familiar with. Is y equals dx over dt a linear function? When x changes to a times x, y equals dax over dt equals a times dx over dt equals ay. So it satisfies the homogeneity. Suppose y1 corresponds to x1 and equals dx1 over dt, and y2 corresponds to x2 and equals dx2 over dt. Then y equals dx1 plus x2 over dt equals dx1 over dt plus dx2 over dt equals y1 plus y2. So it satisfies the additivity. Because y equals dx over dt satisfies both the homogeneity and the additivity, so it's a linear function. For these examples, we know that linear functions includes linear algebraic functions, linear differential functions, and linear integral functions as well. And we've pointed out that y equals x plus 1 and y equals x squared are not linear functions. The following discussions are all on linear functions, including both linear algebraic functions and linear differential functions.